A network switch, known by various names such as switching hub, bridging hub, Ethernet switch, and MAC bridge according to the IEE, serves as a crucial piece of networking hardware that facilitates the connection of devices within a computer network. Switches employ packet switching to efficiently receive and transmit data to the intended destination device. Functioning as a multi-port network bridge, a network switch utilizes MAC addresses to perform the forwarding of data at the data link layer, layer 2, of the OSI model. Some advanced switches also possess the capability to direct data at the network layer, layer 3, by integrating routing functionalities, earning them the designation of layer 3 switches or multi-layer switches. Particularly common in Ethernet networks, network switches have been instrumental in revolutionizing the landscape of network connectivity. The origins of the network switch trace back to 1983 when the first MAC bridge was conceptualized by Mark Kempf, an engineer at Digital Equipment Corporation's Networking Advanced Development Group. Following this innovative breakthrough, Digital Equipment Corporation introduced the initial two-port bridge product, the LAN Bridge 100. Subsequently, the company expanded its product line to incorporate multi-port switches for both Ethernet and FDI, exemplified by the GigaSwitch. Notably, Digital Equipment Corporation opted to license its MAC bridge patent under a royalty-free, non-discriminatory framework, consequently fostering IEE standardization and enabling several other companies, including Kalpana, to develop their own models of multi-port switches. Network switches are predominantly tailored for Ethernet networks. However, they also exist for various other network types, such as fiber channel, asynchronous transfer mode, and InfiniBand. Distinguishing itself from repeater hubs that indiscriminately broadcast data across all ports, a network switch functions by learning the Ethernet addresses of connected devices and selectively forwarding data solely to the intended recipient's port. This discerning approach enhances network security and efficiency significantly, outperforming the simplistic retransmission method employed by Ethernet hubs. Anchoring the architecture of modern Ethernet local area networks, IBLANs. Network switches are instrumental components that ensure smooth communication between interconnected devices. These switches, especially in mid to large-sized LAN setups, are typically managed and interlinked to optimize network performance. Conversely, smaller setups like small home office environments often rely on a singular switch or a versatile device like a residential gateway to access broadband services such as DSL or cable internet. To enable seamless connectivity, many switches feature pluggable modules like small form-factor pluggable SFP modules, which house transceivers facilitating physical medium connections like fiber optic cables. Evolving progressively, these modules have advanced from gigabit interface converters to the latest OSFP modules, catering to the ever-increasing demand for high-speed and efficient data transmission in contemporary networking environments. Switches serve as crucial network connection points for hosts at the network edge, as well as deeper within the network to facilitate connections between edge switches. These devices, designed for commercial purposes, offer built-in or modular interfaces that enable the linking of various network types such as Ethernet, fiber channel, and Rapidio. Providing connectivity across different layers, switches with Layer 2 capabilities are essential for bandwidth needs within a single technology. However, for interconnecting diverse technologies like Ethernet and token ring, Layer 3 or routing becomes more efficient. When there is a requirement for in-depth network performance and security analysis, switches can be utilized between WAN routers to house analytic modules. Some vendors offer add-on modules for functions such as firewall protection, network intrusion detection, and performance analysis that can be plugged into switch ports. Through port mirroring, switches can create data duplicates for external devices like intrusion detection systems and packet sniffers. Moreover, modern switches may support Power over Ethernet, PoE, streamlining power supply requirements for devices like VoIP phones and wireless access points. Back in 1989 and 1990, Kalpana revolutionized the field by introducing the first multi-port Ethernet switch, the 7-port Ether switch. Today, commercial switches predominantly feature Ethernet interfaces, offering Layer 2 bridging across multiple ports. Beyond bridging, switches can operate at various layers, with devices capable of more than bridging being termed multi-layer switches. These network devices utilize MAC addresses for data processing and forwarding at the data link layer, catering to end-user access and uplinks with varying bandwidth requirements. Employing cut-through switching, high-performance switches can reduce latency by sending frames to their destinations while still receiving data from senders. Interswitch connections may be managed using protocols like Spanning Tree Protocol, STP, to prevent switching loops and ensure network stability. Shortest path bridging and Trill present Layer 2 alternatives to STP, allowing for multiple active paths between points, thus enhancing network efficiency and redundancy. Switches come in various types, such as standalone desktop units for home or office settings, rack-mounted switches for equipment racks, DIN rail mounted for industrial use, and small installation switches for cable ducts or communication towers, often seen in fiber to the office setups. Rack-mounted switches can be standalone, stackable, or large chassis units with interchangeable line cards. Unmanaged switches are straightforward with no configuration options, ideal for small office or home office environments, and come in desktop or rack-mounted varieties. Managed switches offer ways to alter switch operations through a command line interface, SNMP agent, or web interface. Subcategories of managed switches include smart switches with basic management features and enterprise managed switches with a full range of customization options and centralized management capabilities for larger networks. Enterprise switches, more advanced and costly than smart switches, are beneficial for networks with numerous connections, streamlining administrative tasks. Managed switches enable centralized configuration management, port settings control, quality of service adjustment, access control features, protocol configurations, and network time synchronization, among other features. Monitoring network traffic in a switched environment can be challenging since only sending and receiving ports can view the traffic. Techniques like port mirroring, where a switch duplicates traffic from a monitored port to a designated monitoring port, assist in traffic analysis. Switch monitoring protocols and features like RMON and S-Flow are used for efficient traffic monitoring. These monitoring capabilities are generally absent in consumer-grade switches, necessitating alternative methods like using network taps or Layer 1 hubs for monitoring.